Hi everybody, thank you for watching my video on physics. In this video, we shall discuss what is an electric circuit. I shall show you an experiment to start our discussion. In this experiment, a pencil will be connected across a power supply by two connecting wires. After the switch of the power supply is turned on, you will see how electrical energy is converted into other form. Let's start the experiment now. In the above experiment, electrical energy is converted into heat and light through an electric circuit. What is an electric circuit? All electric circuits consist of three components: a power supply, connecting wires, and an electrical device. The power supply provides electrical energy and delivers to the electrical devices through connecting wires. The electrical device can be a light bulb, a rice cooker, a water heater, or an electric fan. In our experiment, the electrical device is the core of a pencil. Note that the core does not consist of lead. Instead, it is made of graphite. Graphite is a special form of carbon. It is the only non-metal that conducts electricity under normal conditions. A filament light bulb works on the same principle as the graphite in our experiment. The filament in the light bulb converts electrical energy into heat. When the temperature of the filament is raised to higher than 1000 degrees Celsius, it emits light. In fact, at very high temperature, all objects emit light. The higher is the temperature, the more light is produced. All electrical devices convert electrical energy to energy in other forms. For example, an electric fan converts electrical energy into kinetic energy of air. The motor of an electric vehicle converts electrical energy into kinetic energy of the car. Computers and iPhones are also electrical devices. Do you know what energy conversion is taking place inside the CPU of a computer? You may have guessed correctly. Electrical energy is converted into heat inside the CPU of a computer. What is electrical energy? In the experiment of a Van de Graaff generator, when electric charge accumulates on the dome stores electrical energy. This can be demonstrated by placing an earthed metal ball nearby. You can see sparks between the dome and the metal ball. We say that an electric arc is formed. Actually, an electric arc represents energy in the forms of light and heat. This energy comes from the electrical energy originally stored in the dome. The electrical energy is converted into other forms as electric charge moves across the air. Our conclusion is that if electric charge accumulates, it stores electrical energy. Let's look at a dry cell. For example, a 1.5 volt AA dry cell converts chemical energy into electrical energy. You can see the positive and negative terminals. At the positive terminal, positive charge are accumulated. If an electrical path exists across the terminal, the positive charge will move to the negative terminal through the path. Inside the cell, the positive charge is continuously moved from its negative terminal to its positive terminal. Initially, the positive charge are not willing to move. Work must be done on the charge to cause the movement. In this process, chemical energy is converted into electrical energy. We say that the cell consumes chemical energy until it goes fat. How is electrical energy transferred from the power supply to the electrical device? If the switch remains open, energy conversion cannot take place. The energy conversion is only possible when every adjacent points are interconnected. We say that the circuit is completed or a closed circuit is formed. On the left side of the circuit, the charge have more energy than those on the right side. In other words, this charge carries electrical energy. When this charge passes through the electrical devices, they give up their electrical energy and deliver their energy to the electrical devices. The electrical device then converts the electrical energy into other forms such as light and heat. As soon as the charge leaves the electrical device, it has no more electrical energy. But when they pass through the cell, their electrical energy is replenished. There are several points we need to note about. Firstly, when an electric charge carries electrical energy, it will not move faster. In fact, all electric charge in the circuit are moving at a constant speed, whether it carries electrical energy or not. That is, the charge on the left side and the right side of the circuit are moving at the same speed. Here, the electrical energy is not visible. We say that the electrical energy carried by the charge is electric potential energy, similar to gravitational potential energy. The electrical energy stored in the charge enables the charge to do work as they move through the electrical devices. This work is energy transfer from electrical potential energy to other form. During the process, the charge does not slow down. Instead, it keeps on moving at a constant speed. Secondly, all electric charge are moving throughout the circuit. You can imagine the scene as cars moving on a highway. All the cars must be moving in order to keep the traffic moving. When the electric circuit is turned on, all the charge must be moving. Before they reach the electric circuit, the charge carry electric potential energy. After they leave the electrical device, they have no more electrical potential energy. But when they pass through the cell, their electrical potential energy is replenished. The final point we need to note is that the cell is not producing charge. The charge are free electrons in the circuit. Electrons are both charge carriers and energy carrier. Their role is to carry the electrical energy from the cell to the electrical devices. The flow of charge is called electric current. In the next video, we shall learn how electric current is defined quantitatively and how it is measured. Before we end, I would like to ask you two questions. Question 1. Do you think a cell is similar to a factory or a restaurant? Question 2. Read the section on water analogy on page 32 of your ebook. What are the major differences between the water analogy and a real electric circuit? Be the first to write your answer in the comment below. You are also welcome to comment on the answer of other people. I hope this video can help you build up a correct concept on electric circuit. Thank you for watching.